Hey guys, so today we are going to start off with trigonometry. This series will be basically covering the P3 syllabus. So we are going to go over trigonometric identities, the normal double angle identities, and the Pythagorean identities. Then we are going to go to the graphs of trigonometric functions and also the harmonic form. So let's start with trigonometric identities. Now, there's a difference, a major difference between identity and an equation. So the difference is that an equation will always be true for only one value, or maybe more than one value, but not for all values of x, right? So here I have an example. For example, sine square x plus cos square x is equals to 1. This expression is always going to be true for any value of x you put in. So let's say if you put x is equals to 30 inside this and inside this, then you're going to get 1, even if you put x equals to 1, 2, or any number. So for any x value, this whole expression would result and evaluate to 1. But let's look at this example. X plus 3 is equals to 5. And this example is only valid when x is equals to 2. So if you put x is equals to 3, then it would be 3 plus 3, which is not 5. So 3 plus 3 would be 6, and this equation won't be true. So this x plus 3 is equals to 5 is only true for one value of x, but this one over here is true for any values of x. So this is what we call an identity. So identity will be true for all values of x, or I can say it would be true for all variables. All right, now let's start with some basic trigonometric identities which you need to know. So the first identity is sine theta is 1 by cosec theta, and cosec is basically the short form for cosecant. Then we have cos theta, which is equals to 1 by sec theta, and sec, as you can understand, is the short form for secant. Then we have tan theta, which is 1 by cot theta, and cot is basically cotangent. And there's one more, that is tan theta is equals to sine theta by cos theta. And this one over here you can easily prove using a right angle triangle. So let's say I have a right angle triangle like this, and this is my theta, and let's say this is A, this is B, and let's say the hypotenuse is 1. All right, just for simplicity. So we can say that sine theta is equals to opposite by hypotenuse, which is A divided by 1, which is A, and then we can say cos theta is adjacent by hypotenuse, which is B divided by 1, which is B, and we can say tan theta is opposite by adjacent, which is A divided by B. Now look at this closely. Sine theta is A, cos theta is B. So if you divide sine theta by cos theta, you're going to get A by B. So sine theta by cos theta is A by B. So as both tan theta and sine theta by cos theta both are A by B, we can say that tan theta is equals to sine theta by cos theta, because both of these are equal. Now let's consider a right angle triangle with a hypotenuse of 1. So let's say this is our right angle triangle, and this angle is theta, and let's say this is 1, and let's again call this A and this B. So previously we had seen that sine theta would be equals to A by 1, which is A, and cos theta would be B by 1, which is B. So what we can do is we can say that using Pythagoras theorem, we could say that A squared plus B squared is equals to 1 squared, which is 1. So we could say that sine squared theta plus cos squared theta is also equals to 1, because A is equivalent to sine theta and B is equivalent to cos theta. And this is our first trigonometric Pythagorean identity. And just we will do some manipulation with this expression, and we will try to figure out some other identities. So let's say we are dividing this whole expression, expression 1, by sine squared theta. So if we divide this expression by sine squared theta, we would get sine squared theta plus cos squared theta divided by sine squared theta is equals to 1 by sine squared theta. Now this is equivalent to sine squared theta by sine squared theta plus cos squared theta by sine squared theta equals to 1 by sine squared theta. Now 1 by sine squared theta is cosec squared theta, right? We had just seen previously, we had seen that 1 by sine theta is cosec theta. So 1 by sine squared theta would be cosec squared theta. Now you can cancel the sine squared theta by sine squared theta, and this would be 1. All right, sorry. So this would be 1, and cos squared theta by sine squared theta is cot squared theta. We had just seen that. Tan theta is sine theta by cos theta. So cos theta by sine theta would be 1 by tan theta, right? And 1 by tan theta is cot theta. So we can just simply say that cos squared theta by sine squared theta is cot squared theta. So we found our second identity, that is 1 plus cot squared theta is equals to cosec square theta. Now let's do the same thing, but instead of dividing by sine squared theta, now let's divide it by cos squared theta. So let's write our first identity again, which is sine squared theta plus cos squared theta, which is equal to 1. And now let's divide this whole equation by cos squared theta. And if we do that, we're going to get sine squared theta by cos squared theta plus cos squared theta by cos squared theta is equals to 1 by cos squared theta. So you can cancel this off, and you can write sine squared theta by cos squared theta as tan squared theta plus 1 equals to sec square theta, because 1 by cos squared theta is sec squared theta. So we have arrived at 3 identities. This one was the first one, and now we have found 2 more other identities, right? So these 3 identities are very important for your P3. Also, if you're doing AS, it's also important for your P1. And now let's try to sum up all the identities we have learned so far. So far we have learned this Pythagorean identities and the ratio identities. So you have to remember this and this. So there's another way to remember all these 3 identities. All of these identities is by drawing a simple hexagon. You can draw a hexagon like this. And what you need to do is, you need to join the diagonals of the hexagon. And where all the diagonals intersect, mark that point as 1. And remember, from the diagonal horizontally to the left, you write tan, and then you write tan, sine, and cos. So you have to set up the hexagon like this, with 1 at the center, and tan at the left, and sine and cos at the top, with sine at the left and cos at the right. So exactly in this pattern. And you have to remember that the opposite end of a diagonal would represent the reciprocal of the trig function. So here we have sine over here, right? So we have sine over here. So opposite to the diagonal is 1 by sine, which is cosec. And here we have cos. So opposite to the diagonal we will have sec. If we have tan here, so opposite to this diagonal would be cot. So let's just write those down. So this will be sec, and this will be cot, and this will be cosec. So another way you can remember is that on the right hand side all of these are basically starting with C. So you can also remember it like that. Now after you have set up your hexagon, what you will do is you will shade the hexagon like this. So this triangle, and this triangle. So you have to shade this exact 3 triangles. And now you are ready to interpret this diagram. So this diagram says that left side squared plus right side squared will be equals to downside squared. For example, this triangle that is shaded, this one, the left side is sine and the right side is cos. So sine square plus cos square is equals to 1 square. Also, if you do the same thing with this shaded triangle, you will realize that tan square plus 1 square is equals to sec square. So always left square plus right square is equals to the bottom square, the down 1 square, right? And also if you focus on this triangle, you can say that 1 square plus cot square is equals to cosec square. So from this diagram I can write down sine square plus cos square is equals to 1, and indeed you have to give sine square x or sine square theta, so you could have written like this. And then when you focus on this triangle, you can write tan square x plus 1 is equals to sec square x. And then you can consider this triangle and you can write 1 plus cot square x is equals to cosec square x. So this is just a way of remembering. You can directly memorize all the identities, or you can take help of this hexagon also. It doesn't matter. And you can do more with this hexagon. For example, all the ends of the diagonals would multiply and give you 1. So you could have written sine x times cosec x and it should be 1. So I could write sine x times cosec x. This would be 1. And you could have also made this subject. So if you made sine x subject, you can write it like 1 by cosec x. So you got your reciprocal identity from this diagram also. Furthermore, what you can also do is you can interpret some other types of relations between these functions. So always in this diagram, this left hand is equals to the right hand's 90 minus theta. So what I mean is that if you write sine x, then the sine x will be equals to cosine of 90 minus x. So when I move like this horizontally, I have sine on the left and I have cos on the right. So I can write that sine x is equals to cosine 90 minus x. Similarly, I can consider this one, and you can write tan x is equals to cot 90 minus x. And you can also consider this one, and you can write sec x is equals to cosec 90 minus x. And you could also think of this in the reverse way. You could also say it like this, that you could also consider the arrow in this direction. You could say that cot x is tan 90 minus x. So sometimes you need this. So it's a really handy way to remember all these things, and even if you forget, you can always look at this diagram and find out what the answer is. Formed our third